Welcome. Today we're going to take a look at the Java primitive types so we can understand what the small little pieces in Java code are and how we can actually work with them. We'll go ahead and do some details. So here we have all 8 primitive types that exist in Java. You can see that some of them are in bold with no details, and we've got the rest of them that have some small details on the range. So we've got Boolean. We have byte, which has a range of -128 to +127. Short, which is plus or minus 32,000. Int, long, plus or minus 9 quintillion. Float, plus or minus 2 times 10 to the 38th. Double, and then char, which is really just a short that's pretending to be a letter. And we'll talk more about those later as we go through. So one of the big things you need to know about primitives is that primitives are values-only based data types. So they only have a value. There's nothing inside them. It's just that value itself. There are no methods. There's no internal state. There's nothing that belongs to it. There's no dot operator we can use inside that. And whenever we work with them, we're sending a copy of them to parameters or when they're returned from something. So if I give you a 7, I still have my 7 right here. If I give you a 3.1415, I still have my pi value right here. If I give you a false, you have my false, you have your own false, and I have my own. I can change it as we wish. You're always only getting copies of primitive values. Now, the first one we have on here is Boolean. This is the foundation of our logical structure. It's true or false values. We use De Morgan's law as how we can simplify complex Boolean logic, and we have an entire lecture just on that. But the Boolean data type is just a Boolean. So it's either true or false values, and that's what we have with that. The next one we have in here is int, and this is the whole numbers, aka the integer type that we're working with. These are the numbers you work with in the elementary school, especially early on. We have plus or minus 2 billion and change for those values on that, but there's more negative than positive because of 2's complement. The way we actually write those values inside binary to store that is how we have more on the negative side than we do on the positive side. And so not something you have to actually know in a lot of detail for it, but if you want to do some research on that, it's a great way to understand exactly how the binary numbers work and how we can store that information there, and that's why there's more negative than positive. We can compare equality with our ints with either equals or not equals with or not equality with not equals. And all math involving int values results in whole number values only. So 2 divided by 7 is 0. 11 over 3 is just 3. We don't have any decimal values whatsoever. We don't round up or round down. We just chop it all off and we don't deal with it. So keep that in mind when we're dealing with an int. Doubles are the next data type. This is our floating point value. We have plus or minus 2 times 10 to the 306 value. Take a look at how big that number actually is. We can do some comparisons using Google and you can see what that range is for it in the real world. It also includes positive and negative infinity and nan. Nan, what's that? Well, it's not a number. It's what you get when you divide 1 by 0, because if you divide 1 by 0, you get positive and negative infinity at the same time, which is not a number. I know, pretty cool. AK, this is the domain of the real if you're talking in math land. You cannot use equals for comparisons on this. You can use not equals, of course, they're almost always not there. But if you want to compare equality, instead you have to do the absolute value of the subtracted difference and check in how close that difference is to the desired condition. You can see how close they are, but you can't go for exact equality. Take out my video with using math with doubles and we can see exactly how that works and why you have to use that comparison on that there. Hope that's helpful. You can also do casting. So you can convert from one numeric type to another numeric type via casting, and left to right and parens matter as we're doing with this because again, PEMDAS is kind of a thing. And so int goes to double, it adds a 0.0 to the value, and double down to int removes all decimal information. So we have double example is equal to casting of double of 5 divided by 7. So we'll do the division of 5 divided by 7, which is 0, and turn that into a double, which is 0.0. We have double other example is equal to the double value of 5, which is going to be 5.0, and we take that value, 5.0 divided by 9, which now is a double value, so we have 5/9 for that, for other example. I have int another is the int value of 3.1415, which gives me, that's right, 3, the correct value for pi. And then we have int more is the casting of example minus other example, so we'll take what's inside example, subtract other example from that, that's going to be 0 minus 5/9, and that's going to be, well, 0, haha, because that's an int, so there we go. So we have that right there stored into an int, and that's how we do casting with that. We have wrapper classes as well. Wrapper classes are how we can actually hold primitives as an object. We can also use this to extract primitives from string value types. We also have the really cool magic we have the really cool magic of auto boxing, auto unboxing, so we can make this really easy to use. If you ever have a wrapper class, you can automatically put a primitive right into it, or take a primitive right out of it, or vice versa. You're required to use wrapper classes if you want to store your primitives in an array list or other members of the collection data types, or any other collection type, excuse me. And it's just going to be the capitalized full name of the primitive. So capital B Boolean is how we store a Boolean value, capital I integer is how we store an int value, and capital D double is how we store a double value. And that's just a quick overview of how we can work with primitives in Java and what they mean. Again, make sure the only 3 you really need to use are int, double, and Boolean. Have a great day. Cheers. See you next time. Bye-bye.